Hey guys, this is a new topic, Java Object Class, that is part of the Advanced Java. Let's see what we got. So, all of the classes that we create in Java, directly or indirectly, will inherit the object class. So, what is object class? Object class is a parent class at the beginning of the hierarchy of the all of the classes that when we create a new class, it will inherit the object class. All right. So what does it mean exactly? Exactly, it means that we have one object class in Java, object, and if you create a class, let's say for example employee, yeah, behind the scene it will inherit the object class. Here is an example, right? So behind the scene, Java create this extends object behind the scene, all right? So now the question is, why did I say uh, directly or indirectly? This directly and indirect. So in this case, for example, it is directly, inheriting the object class. But if you create another class, let's say call it manager, and if manager is inheriting the employee class, then manager will inherit indirectly from object class. Okay, so this is the reason why we said directly or indirectly. So what would be the consequence here, right? So the consequence would be it is an inheritance. Yeah, it's a regular inheritance. The only difference is that it's not mentioned in your code. So based on this statement, it means that all of the visible methods of object class will be inherited into all of our classes, directly or indirectly. So what are those visible methods? Yeah, here is the list of the methods that we are talking about. One of them is toString, equals, clone, and there are other things here. Get class, hash code, notify all, wait, and some of these like wait have several signatures. Yeah. So in this lecture, we're gonna talk about the first three, toString, equals, clone, and if we have time later, we will cover some of the other methods. All right. So let's start with toString. The easiest one is toString method. I am sure that you have seen and you have used it a lot so far, but let's have a very quick review. So what is the goal of overriding to the toString? ToString actually is a descriptive string from the object state. What does it mean? We know that what is the object state? The combination of all of the values of the instance fields, right? So from time to time, we need to see what is the state of the object, okay? And for many reasons, for example, for debugging our program, or sometimes for logging all of the events that are happening during the application's execution. Okay, so what is the default behavior? Its default behavior is a little bit weird. If you just invoke the toString without overriding it, it will give you a package name, class name, and a hash key, which is a hex number. Let me take an example. For example, if we just instantiate the employee object and then we invoke the just emp to a string, what we got? This So the package name, whatever it is, the employee, the class name, and a weird number, which is the ID actually of that object. Okay, so the only thing that you need to know that is, that makes the toString a little bit important because Java, automatically invoke that toString when it expect a string value. Let me take an example here. So in the previous example, we invoked the emp dot to a string. But if you don't mention the to a string, since Java needs a string here for the println, automatically it invoke the to a string. Okay, so how can we override the to a string? It's very easy, like any other methods that we override. But the only thing that you need to remember is when the class is subclassing another class or extending another class. In that case, you need to invoke the superclass to strings first. Let me take an example. Here, manager class is extending employee class, all right? And you just put an annotation over right here. Even for the Java 8, you don't need to mention this annotation, anymore. But for sure, put it here. And here is the signature of the toString, and here is the point that I was talking about. So since there is a superclass, right? If you want to get the whole information of the object state, you need to call the superclass to a string first, and then you can add any string after that. All right? Okay, that's it. So this is the toString. Equals method. What is equals method? As its name is saying, its goal is to check the equality of two objects. Let me start with a very simple example. Let's say x and y are two variables and they are referring to two objects. And the question is, what is the meaning of this equality checking? X equal to y. And we know that if x and y are primitive um, values, it means that whether or not x is equal to y or not, right? But now they are referring to two objects, right? So what is the meaning of this? So this is the whatever the Java behaves in this situation. So it checks that are they referring to the same object or not? What does it mean? So you know that an object, if we show an object like this, when we create an object, then we create a variable or reference variable that is pointing to that object, which is the address of the memory behind the scene, right? Now, if x and y, both of them are, reference variable, then when we say x is equal to y, it means that is this the case that x and y are referring to the same object? Or in other words, as I said, it is a reference to a memory. So this reference and this reference are exactly equal. So in fact, it is checking the memory address value. All right. So this kind of checking is called identity test. What is identity test? Why identity test? Yeah, you remember when we were talking about the objects, we said object is an entity that has three properties. state, behavior, and identity, which we said it's a unique number that Java assign to every object, right? So in fact, when we say x is equal to y, it means that we are checking that identity unique number. If they are the same, then this will return true. Otherwise, it returns false. Okay, so let me take another example here. So what does this comparison return? Look at this. We instantiated an employee here. We don't care about these values here. And then we assign this employee to another employee. All right. So now the question is this the case that this do something will be run or not? Or we will say EMP is equal to EMP2. So is this the case? Okay, so let's see what would happen. Uh, employee EMP, new employee. When we create an object, as we said, Java create an address that is referring to this. So this is our EMP, right? And this is the that object, whatever it is. All right, now in the second line, we are assigning this value, which is an integer value, the memory address, to another variable. So it means that this is the employee 2, and the value is exactly the same as this guy is equal to that. So it means that this value, this variable is referring to the same object, right? So is this the case that it returns true? Yes, it is. It returns true because both of these objects are referring to the same object, right? Okay, cool. Now let me take another example. How about this one? Employee is instantiating an employee and EMP2 is instantiating another object. Yeah, look at this. So this is not the case that we talked in the previous slide. Now we are talking about two objects. So when you use this new operator, Java create a new object. So this guy is referring to this employee object, whatever it is. And when we use another new, then it creates another object. So EMP2 is referring to different memory address, right? So is this the case that they are equal? No, they are not equal because this guy is not this guy. All right, let's see. Yeah, and this is the note that I just said. When we use new operator, JVM creates a new object and definitely a new address. When we want to compare two objects, now we know that uh, that equal sign does not work because that's a identity test, right? So Java created a method for us, which is a standard method called equals method. Let me take an example first. We create an employee here and we create another employee here. Now we want to check whether they are equal or not. Then we would use this equals like this, right? And equals check the equality of these objects. But the question is, are these two guys equal now? If I ask you, are they equal? Yeah, definitely we don't know. It depends on, right? It depends on the contents of this employee, contents and of this employee, and also the most important one is what is the definition of equality of the objects. When we create an employee, when we design a class like employee, we need to know exactly what is the meaning of the equality of two employees object, right? So I will talk about this in a few minutes. Let's go over to this. What is the default behavior of the equals method? So here is the default behavior of the equals method. What is this? Oh, now our knowledge is enough. This is just checking the identity. This is the identity test, right? So definitely if you don't override the equals method, you will get the wrong answer, right? Okay, so what is this? This is object. This object is coming from here. So we usually, checking the equality of this object, the current object, with another object that we pass here, right? So this is, the current object, and this object is coming from the other objects that we are gonna check. So bottom line, this is just a identity test, and it is useless. Most of the time, let's say 99%, 99.99% of the time, it is useless. We are not gonna use this. So we have to override the equals method. So how can we override? That's the question. So it's very easy. It's just like any other, overriding. So you just use this annotation, and the equals return a boolean, yes or no. And you mentioned your class here as the other class that you want to compare. And you check some condition here, and I will talk about this condition later. And if that condition happens, you return true, otherwise you return false. Let me take a a solid example. So, as I said, we need to define the equality meaning. For example, if I am overriding the equals in a rectangle class, I need to define when we can say two rectangles are equal. It depends totally to your application, totally. So in some cases, you might say, okay, two rectangles are equal if their width and height are equal, right? That this is the normal thing that we learn from the geometry. But in some applications, you might define, no, I would say two rectangles are equal if their surface are equal. Let's see an example, a very simple override. Uh, you see, I checked the surface of this object with the surface of other objects that we pass through that argument, right? And if these surfaces are equal, then we return true here. Otherwise, we return false. Okay, so this is I follow the template that I mentioned before, but in some cases we can, reduce this code. For example, in this case, we can reduce this code just to this, just to return this comparison, right? So if it is true, it returns true, otherwise it returns false. Okay, so what happened if we have a superclass then? That's our next note. Let me take an example. For example, if the rectangle has a superclass, right, then first we need to check the superclass, equality, right? Because some of these class members and some of the properties of that class might be coming from the superclass, right? So you need to implement the equals in the superclass as well, and then in the subclass, you need to check the superclass. So you invoke the superclass equals like this. If it fails, then it fails. So you should, return false. And if it succeed, then you go to the next step, that is checking the surface that we just talked about. All right. Okay. So now let me very quickly talk about how you can use the Eclipse default implementation. Here I created a rectangle class, just the width and height. And I want to show you how to use Eclipse for implementing the equals method. All right. So Alt Shift S is the shortcut, but if you cannot remember that, go right click here, source, and here is a lot of things that you can use. Some of them are very important. For example, constructor. You can create constructor from superclass, toString, and many things, right? And the one that we need is here, hash code and equals. Okay, and it picks both of these by default, and we need both of them, and just generate. Okay, so it creates two methods for us. The hash code I didn't cover here, but it is one of those methods. Very quickly, I tell you what it is. So, hash code based on an algorithm create a unique number for the objects, right? Based on the values that an object has. All right. So this is this is very useful if you want to use hash set or hash map in your class, then this hash code becomes very important thing. And also for the equals, right? So here is the overridden methods for the equals, that is our topic here right now. So let's look at that. So first of all, you need to know that it passed the object, right? And not the, this class name. I usually change the class name with this object when I, use the Eclipse for the equals one. But let's say that this is an object. So first it, compare whether this is equal to this object, it returns true. And also it checks that this object is null, it returns false. And also it should check that the type of this class and this object class should be exactly equal. If they are not, it returns false. So, but if we put here employee, then we don't need this one, right? And also it casts the input object with the rectangle. And again, if we put employee here or rectangle here, we don't need this cast as well, right? Okay, so here, look at this too. It, by default, its definition is two rectangles are equal when their width and height are equal. So look at this. It is checking the height of the this and the height of the other one that we just input to this method. And if they are not equal, it return false. After that, if it succeed, then it checks the width. If they are not equal, it's Otherwise, it return true, right? So it's a very straightforward algorithm for this. All right, that's it. So this was the equals method and how we can implement that. And also, I put this code for your reference and the explanation in the slides. Clone method. What is clone method? Before going over the clone method, we would need to have a very quick review about a concept that we will be using a lot. And that concept is called mutability. What is mutability? Let me start with a very simple example from the string. So I have a string and I copy that string to another variable, right? What would happen? Let me show you this example. So I define s1 by my name is a string, and then I assign this s1 to s2, which is another string, and then I change the s2 to something else, let's say Tom. And at the bottom, I will print both of them. I want to see what is happening here behind the scene, to have a feeling about the concept, very important concept of mutability, right? I put all of the explanation that I am going to give you in the next slide here for your reference, right? But I would rather to explain everything here visually, let's say. Okay, so line by line, the code. So the string S1 is created and its value is Ahmad. Okay, so a string object will be created. Its value is whatever we put it here, my name here, and a reference S1, which is just a reference referring to that object. So far so good. Yeah. Now we create another string object S2. We assign S1 to S2, right? So the S1 is still the same thing. We didn't change that. But since S2 is equal to S1, we learned that before, that these are just the memory address, right? The memory address is just an integer number. So another reference will be created which is pointing to exactly the same object, all right? So far, it's consistent with our knowledge, whatever we learned so far. But now what would happen? Now we are changing S2 to another value, right? So the S2 is no longer Ahmad, it is Tom right now. At this moment, Java create a new object. So it leave the S1, which is pointing still to Ahmad, it creates another object. Its value is Tom, and S2, this guy S2 now is referring to this object. So this is whatever happening here, right? So let me now, based on this knowledge in our head, let's define what is the meaning of mutability. So if the state of an object cannot be changed, we call that class as immutable. Immutable, it means that, unchangeable, right? And if the state can be changed, we we say it is mutable class. Okay, so let's shine our knowledge what is happening here. Let's get back to our string class. So a string class, what do you think is the underlying data structures uh, for the string class? Probably it's not probably, definitely is an array of characters, right? So it's the instance field of the string class is an array of the char. Now we are asking this question, can we change this instance field, which is the state of the string, right? Can we change that? In the previous slide, we saw we couldn't change that. When we try to change it, the string class create a new object. So it didn't let us to change this array. So for this reason, based on this definition, we would say a string class is immutable, right? When an object is immutable, it means that we cannot change its state. If we try to change its state, if we design it correctly, it creates a new object, right? So this is the definition of the mutability and immutability. And for your information, I'm sure you know that all of the primitive data types are immutable. So x is equal to 5. If you change it, x is to the 7, this is another object now. It creates another thing, right? So all of them are immutable. Okay, so before finishing this required background, let me give you a very valuable side note about this string. So based on our current knowledge, a string is immutable, right? And it means that if we concatenate two strings, Java create a new object, right? And let me take an example and show you that how horrible code could be. Look at this. We are going to add 0 to all 10,000 10,000 number integer from 0 to 9999, and we want to concatenate them as a string, right? A naive approach would be this. Look at this. We create a string, right? And then we just concatenate all of these integers to the previous one, right? So you know that this is a syntax sugar, which is equivalent to this one. All right. So based on this knowledge that we got so far, so every iteration of this loop will create a new object. And that's very horrible design, right? So what is the best solution for this? The best solution is using a string builder or a string buffer. So both of them are, almost equal. The string buffer is thread safe. Yeah, you just if you have a single thread program, just use the string builder. So let me show you how it works. So the same problem, but here instead of the string, we uh, change it to string builder. String builder, and we put append the I to the previous the content of the string builder. All right, so this is much more efficient than the previous solution. The other things that I want to mention, if you don't know, we can use the underscore for the separator for the numbers after Java 7 actually. Now let's get back to our clone method, and let's talk about copying an object, right? So what is the meaning of cloning? Cloning means copying, right? So our goal is to copy one object to another object. I'm going to cover three different scenarios for copying two objects. And there are a huge difference between them. Let's see. So first one is reference variable copy, second is shallow copy, and the third one is deep copy, right? Because of it's really its importance. Because if you don't understand this and if you don't use it properly, you will get into a very huge trouble in your code. All right. So we will go over all of them in detail. Let's start with reference variable copy. Okay, I'll explain it via an example. Look at this example. I have an employee class. Our employee class has these three instance fields: name, salary, and hire date. So you see the hire date is date, and here we have an constructor, but please note that in constructor, for simplicity, I use the string for hire date, and I assume that inside this constructor, we convert this string to the date, right? So this is just for simplicity. It's not a big deal, right? Okay, so here is a client of the employee class. We can, instantiate employee class so simple, right? So just name, salary, and the hire date. Okay, so after this instantiation, now we are assigning this employee to another employee object. So EMP is going to be assigned to EMP2. So far, we have seen this many times. We had a couple of examples that it shows that what's happening here. So we know that, by our knowledge right now, we know that this is just assigning the reference variable, the reference value to another reference value. Both of these guys are just integers that are memory address, right? Let me show you how JVM acts on this object visually in the next slide. Okay, so when we instantiate an object like this employee, this is what's happening. So this is the employee object. We have one primitive, which is the salary. We have two objects. One is a string, this guy, and one is date, this guy. So inside the employee object, we just keep a reference to this object and another reference to this object. So currently we have three objects, right? And what would happen when we assign this employee to EMP2, which is another reference to the same object? And you know that what would happen. Java create another reference employee 2 and it refers to the same object. In fact, the content of this and the content of this are two identical integer number that are the address of the memory. All right. Okay, now let's see what would happen if we make some changes. For example, I use the employee EMP and set the salary to 20,000. What would happen? So this guy will change this to 20,000. Now here I use the EMP2 and change the name to Tom. So since this guy is referring to the same object, it will change this to Tom. So what's happening here? Any changes, any changes on either one, this guy or this guy, will affect the other one. That's the point when you just use this assignment for copying two objects. Now let's see what is shallow copy. So this is actually, the default implementation of the clone method, right? Let me take an example. So in this employee, if you look at this, we see implements clonable. So if you want to use the clone method, even as a default, implementation of the object class, you need to implement the clonable. Otherwise, it throws an exception. Okay, so this is the first difference. Let's continue our examples now. And this is a client of the employee class. We saw this before, right? We instantiated with some variables, and now if we want to copy EMP to EMP2, we instantiate EMP2, I mean declare the EMP2 and use EMP clone, right? So just remember that we have not implemented or overrode the clone method yet, but this is the default behavior that object class gives us. Now let's see how it works, right? So I put all of the explanation here, but I would prefer to show you, visually in the next slide here. So, so this is the instantiation that we have seen before. We instantiated a, employee class. This is our variable, and this is the salary, name, and hire date. And we know that two other objects will be created, one for a string, one for date here, right? So now let's see what would happen when we clone the employee object to emp2, right? So Java create another object like this. So this is our employee 2 and this is our new object, but as you see, the primitive types is being copied. So this object has its own salary because it's an primitive, right? But since name and hire date, both of them are object, they share the same object for the employee one. That's a very important point that you need to know. All right. Okay, so here is the explanation I just gave you. Now let's continue and let's try to change employee 2. Let's say change the salary, change the name, and change the hire date, and let's see what would happen. So let's start with changing the salary. When you change the salary, since the salary is an independent salary thing, it's a private thing for this object, so you can easily change it without any problem. So far so good. Now let's change the name and see what would happen. When you change the name, yeah, so before the name was pointing to this guy, but since the string is immutable, you cannot change it. When you change it, Java create a new one. So here it created a new string object. Now name2 is referring to this new object. So this would happen for all immutable objects, right? So at the beginning, the default behavior create a new object like this, and it shares the aggregated and the instance fields that are objects. It's shared at the beginning for the efficiency purpose, definitely. But if You make any change, it creates a new object like this, right? Now let's see what would happen to date class. So in so when we change the date class in Java 7, date actually was mutable. But just noticed that in Java 8 they changed it and now it is immutable. Now let's assume, because I want to convey I want to transfer the concept. Let's assume that this date object is mutable, right? If you changed it to something else, this guy will remain shared. And that's the source of many, many problems. That's why I put these three, important thing that you should know this. If you have an mutable object, like, like this assumption that we made here, then if you use just a clone, the default clone, without implementing a new clone, then this problem will cause many, many, put you in many, many troubles. And you try to debug your code and you don't know what's going on. That's the concept that you should learn right now. Okay, so based on this, background that we have learned so far, let's officially define what is shallow copy. So we have x and y as an objects, right? And if y is a shallow copy of x, then this, procedure will happen. All of the primitives, as we saw for the salary, all of the primitives will be copied. So y now have, the y object has its own primitives. We have no problem with the primitives. But for the objects at the beginning, both of them share all non-primitive, objects at the beginning. And if you change them, if it is immutable, then a new object will be created. But if it is mutable, then it remains as a shared thing. So this is the problem that we have with the default implementation of the um, clone method, that we call it shallow copy. And finally, deep copy. What is deep copy and what is the goal of deep copy? When we deep copy an object to another object, our goal is to have two independent object, 100% independent object, right? So, for example, if we have this employee, if we deep copy this object to another object, we would like to have something like this. Totally they are, you see, isolated, and there is no relationship or dependency between them. So this is our goal. So to make this deep copy, first of all, our class should implement the clonable interface. Otherwise, you will get this, exception. And also, you should override the clone method, because we have seen that the default implementation of the clone method is just a shallow copy. Let me take an example. So this is our employee class, and as you see, we implemented the clonable interface. And here is the our clone method. So we put an override and this clone, and that's the point here, you see. So we use the default behavior of the object class method, which is a big help here. So you invoke the clone method of the object class by using the super, and up to this point you are sure that you will have a shallow copy. From here, afterward, now you need to modify this shallow copy to make it a deep copy. So based on the knowledge we have, what should we do? If we have a string, we are okay because automatically Java create a new object after changing. If it is primitive, we don't have any problem. The only problem we have is for the mutable classes, right? So if we assume that the date class is a mutable class, then right after this shallow copy here, we try to modify the, to clone the um our mutable class, whatever it is, right? So we just invoke the clone of that object. That's it. So if you have more, just put it here. So your clone object, I mean method is ready. Okay. So here is the explanation of the code that I just gave you. But let me, give you some notes here. So yeah, I explained this for efficiency purpose. I said that Java first share all of the non-primitive objects at the beginning, and if you change something, Java waits for changing. If you change something, then it create a new one, right? So, and the second point I want to mention here is when you implement a clone, that's my professional recommendation. Fully test it because it's a source of many issues. I was in trouble many times. That's why I know what's happening, right? So try to fully test it from different angles, make some test cases for that and make sure that your clone method is working fine. Okay, finally, let me give you the official deep copy, which is very easy. So if x and y are objects and when y is a deep copy of x, then remember our ideal two different two independent object like this. So everything will be copied. Whatever x has will be copied to y. So that's why we have two different, independent objects. And also if you have some aggregated classes inside the x, right? You need to implement the clone for those aggregated classes as well, right? So yeah, that you should be very careful about this. Okay, so I'm gonna stop here and see you guys in the next lecture.